Hello, thank you for checking out Mr. Ware's videos, and today we're looking at exponential functions, the basics. More specifically, we're looking at growth and decay. Okay, so with an exponential function, you're looking at y is equal to ab raised to the x, and then there's a manipulation of this basic formula here. Okay, and there's one for the growth, and there's one for decay, and there's one for compound interest. It's a lot of different exponential functions, but it's all based on this right here. So I'm gonna give you a couple of those variations right here, right now, and that is growth and decay. Okay, so you got the growth one here and the decay one here. Okay, all right, and the major difference between the two is the minus and the plus. Obviously, the plus for growth, minus for decay. Alright, and let me show you what it looks like on the graph real quick. Okay, so a decay is where it goes down. Now typically we've been dealing with linear functions where it goes straight down like this, right? But or straight up, but this has got a little curve to it because it's exponential, just to give you some insight on what it looks like. Now here's some key components in a growth or decay type of problem here. You got A, the initial amount before measuring the growth or decay, where you start at, and then you got the growth or decay rate. It's often in a percent, and you have to change it to a decimal. Okay, and X is the number of time intervals that have passed, usually in years or months or whatnot. Okay, it can also be represented as T, so I wrote that out here. So on each problem, I'm going to show you the growth formula and this over here, so you can figure out what you need to do, get each component, and then plug it into the formula and then solve it. So let's take a look at our first problem here. Alright, let's see, can you get all this in here? Yes. Alright, so a town has a population of 14,000 and grows 5% every year. What will be the population after 14 years to the nearest whole number? Okay, so the best thing to do is first determine if it's a growth or decay. Alright, so now first you're going to figure out the amount that you begin with. So that's going to be 14. Matter of fact, I'm going to change colors here. That's 14,000. That's the amount you begin with. Then you're going to find the rate, which is 5%, and we're going to change it to a decimal. And you're going to move the decimal places 2 places to the left. So that's going to get you 0.05. That's 2 places to the left. And then finally, the time, 14 years. So you'll put 14 here. Now all you have to do is put each one of those components in to your formula. Okay, so I'm gonna write it out just like that. So the y, or the actual answer here, is going to be equal to A, which is 14,000, parentheses 1, which is in the formula, plus, I meant to talk about that. I'm going to go back over that. But plus, and I'm going to tell you why it's growth. And I'm going to leave off that 0 there. 0.05 and raise to the 14th. Okay, now let me go back here. Now, the town population of 14 grows. There's an indicate increase, grows. Words like that let you know you're going to use the growth formula. Okay, so you got to make sure you read it and figure out which one you're using. That's important. So now we have everything in our formula. All we got to do is type this into the calculator just like it is. Just type it straight into the calculator, hit enter, and you get a really big number, 27,719.04239. So that's the number you get, okay? But they want us to round to the nearest whole number, okay? And that whole number here is 9, and the number we look at is 0. So it's 4 or less, so we let it rest, okay? So we're going to keep everything else 27719 and drop off everything else because it's to the nearest whole number. Okay, so it's helpful to write out the formula so you see what you're doing. It's helpful to write out, say, okay, this is A, this is R, this is X, this is where it goes. That way you keep from messing up. Alright, so let's take a look at another example, and you could pause the video here and see if you can solve it. Alright, so this should be the answer that you get right here, this 11,743, okay? So you got your 9,000 for your amount, 0.03 is your rate, 9 is your years and time. You plug it into the formula, and then you just type it in and hit enter, and then round to the nearest whole number. In this case, it's 5 or higher, 5 or more, so you raise the score, and that's how we get 3 right here, okay? Something I want to point out too. You see how you get this 1 plus 0.03? If you add that together, that's 1.03. Okay? So that's going to be very important later in a future video. It's going to come back. Okay? But just want to, you don't really need to add that. All you need to do is type it in the calculator and hit enter to get the answer. Okay? Alright, let's take a look at another example. Alright, so now on this one we have a decay, okay? So it says a new car purchase for $20,700. The value of the car depreciates at 13.75. Cut that off there, I want to make sure that's right. Yeah, 13.75%. This should say percent. Let me put a little percent sign there so you can see that's percent. 13.75%. Alright, per year. What would the value be to the nearest cent after 12 years? Okay, so since this is decay, everything's the same except we're going to have this minus in here. Okay, but everything's done exactly the same way. You find the initial amount, 20,700. Okay, the rate 13.75. We're going to move that decimal 2 places, so it's 0. I forgot to change colors here, but 0.1375, and then 12 years. Okay, now we're going to plug that into the formula. Y is equal to A 20700 times 1 minus R take the R out, put the rate in, and the rate is 0.1375, close parentheses, and raise it to 12. Okay, then you just type this in your calculator, and once you do, you get Y is equal to 3508.1615992. Okay, now since it's dealing with money here, they want to round to the nearest cent. Okay, and the nearest cent is 2 decimal places. Alright, so we're looking at the 6, but we'll look to the number to the right of it here, and it's 4 or less, so we let it rest. So we're going to keep that at Y is equal to 3508.16. Let it rest. Alright, so now take a look at this one. You can go ahead and pause the video. Oh, one quick point before I go over that. Right here, since you got this 1 minus 0.1375, if you actually subtract that, you'll get 0.8625. Okay, and that number being less than 1 lets it go down. But again, I'm going to talk about that in detail in a future video. But I just want to make you aware of the minus and the plus here. Alright, so go ahead and pause the video here and see if you can solve this one. Alright, so this should be what you get. 182.8. That should be your final answer there. So let's go back and take a look. So we got the 310 because that's the amount we start with. We got the rate 5.7 converted into a decimal. I'm moving 2 decimal places. And put a 0 out here if you want. And then don't know why I put 10. This is wrong. Let me fix that. This should be 9. Change this to black. Alright, so you plug that in into your formula here. You've got the amount, the A, you got the rate, and you got the time. Time, rate, amount. Just like that. Okay, and then you get this big decimal here, and since it says round to the nearest tenth, and this is also wrong. Let's fix that. Since it says round to the nearest tenth, we're going to look at this number here and this number here, and the nearest tenth is 1 decimal place over. So we take this 9, it's 5 or more, so you raise the score, change that 7 into 8. So that's how you get 182.8. But that's it. That is exponential function basic, dealing with growth and decay. I want to thank you for checking out Mr. Ware's videos. Have a nice day.